Hi everyone, I'm Héloïse Verdier. I'm a PhD student at l'ENA and INRAE Labs and at Eurofins Hydrobiology Company in France. And today I will present you an innovative and simple way to sample environmental DNA in aquatic systems. eDNA sampling is a crucial step in the study of aquatic biodiversity. Today, we collect eDNA from water mainly by active filtration methods. But filtration has limitations. First, it is time-consuming and requires human presence. Second, the equipment are difficult to handle. And finally, filtration is challenging in some habitats, for example, in hard-to-access environments or turbid water where filters quickly become saturated. It would be very practical to have a passive sampling tool applicable to a wide range of habitats. With this in mind, we have developed a passive, reusable sampler that naturally collects DNA in water. We designed the samplers from a hydroxyapatite resin, a mineral known for its high binding affinity to DNA. Likely by an adsorption mechanism, the phosphate groups of the DNA molecules bind to the surface of the samplers. Using 3D printing, the shape, the geometry, and the porosity of the samplers have been optimized for an easy DNA sampling in water. The use of the hydroxyapatite samplers, or HAP samplers, is simple. They are first decontaminated by burning and then placed in a water environment minimum for 2 hours. They are then collected, dried, and washed. Finally, the DNA is released from the samplers thanks to a phosphate buffer. This buffer charge in DNA is then purified and quantified. After use, the samplers are burned to start a new cycle of use. Once this protocol was validated, we tested the ability of the samplers to recover DNA in vitro and in vivo conditions. In vitro, with concentrated DNA, and in vivo, with living organisms. The results show that samplers can efficiently collect DNA under both conditions. In vitro, on the left panel, we placed HAP samplers in a DNA solution of known concentration for 17 hours. By quantifying the DNA in the water and on the sampler, we showed that one sample could recover up to 60% of the total DNA. This is 4 times the theoretical DNA quantity that can bind on an HAP sampler. In vivo, on the right panel, we placed the samplers in the presence of 5 macroinvertebrates of the species Azellus aquaticus for 24 hours. By quantifying the target DNA by qPCR, we showed that 7 of the 8 samplers recovered eDNA and allowed a positive detection of Azellus aquaticus, even the weakness of the DNA signal. Although passive samplers are promising, you can see that DNA recovery can be extremely variable. And this variability highlights that DNA adsorption on mineral surfaces can be complex. By analyzing interaction between DNA and surface of HAP samplers, we could improve the repeatability of the process and provide a robust eDNA sampling tool. Thank you.